All right, how's it going, everybody? Now, today's video is going to be a little bit different. I'm not going to be solving any problems or anything, but instead, I'm going to take a look at the formula sheet that you're going to be given from College Board um, during the AP exam. And we're going to take a look at each formula, and we're going to point out the ones that are important, the ones you could ignore, and I just got some extra comments marked on my formula sheet. And it's also like organized based off of the different units or chapters from the book. So I was inspired to make this video by some other stats teachers who put out a similar video, but I just want to put my own little twist on it. All right. So let's start with the first page of the formula sheet. I'm going to zoom in here. Okay, and so the first section here, which I've kind of color-coded in red, is our one variable statistics. Okay, this is just your basic sample mean and your sample standard deviation. Okay. Now, it's probably very unlikely that you'll have to use these formulas to calculate these things by hand. You know, if you have a small enough data set, you can just enter the values into list one, and then you can run the one var stats command on your TIA 83 or 84, whatever. Okay. So yeah, maybe just good to know, but probably not going to be used too much during the exam. Right. This formula here that I scratched out, this is the formula for a pooled standard deviation. So if you have two samples and you kind of want to estimate a combined or overall standard deviation, this is essentially what it is. It's kind of like a weighted average of some sorts. Okay, you will not need that formula at all. Okay. All right. Now this next section, which is color-coded in blue, this is all of the formulas for two variable statistics, right? So two variable statistics are, you know, when we're looking at scatter plots, correlation, least squares regression line, that sort of stuff. Okay. So the first formula here is just the general form of the least squares regression line. However, College Board uses slightly different notation. They use B0 for the intercept and B1 for the slope. Okay. Now, in our class and in a lot of textbooks, they use A for the intercept and B for the slope. Okay. So just make sure you're aware of that minor difference. Okay. This next formula that's been scratched out, that is how you could calculate the slope by hand. Okay. You would never be asked to do that, and so you can completely disregard that formula. Okay. The next one is how you can calculate the intercept by hand, which is actually a pretty simple formula. Okay. So the intercept of the least squares regression line is the average y value minus the slope times the average x value. Okay. So as long as you know the means and you know the slope, then you can calculate the intercept. Okay. Again, I've rewritten it here using the notation we use in class, A for the intercept and B for the slope. Okay. This next formula is for calculating the correlation coefficient by hand. Again, it's very, very unlikely that you would ever have to do that. Okay. If you did have a small data set and you needed to calculate the correlation, what you would do is put the x values in list 1, the y values in list 2, and then you would run the linreg command. That's, of course, short for linear regression. Okay. You do have to make sure that the diagnostic feature on your calculator is turned on, and that's something we did at the very beginning of the year. So as long as you haven't reset your calculator, that feature should be on. Okay. If it's not, you can always just go to the catalog, search up by the letter D, and then turn it on. It takes like 5 seconds. Okay. All right, so let's continue on. This next formula is the equation for finding the slope by hand. And again, you may need to use this for like a multiple choice question or maybe an FRQ, who knows. But it's a simple formula, right? It's the correlation times the standard deviation of your y values divided by the standard deviation of your x values. Okay? So as long as you know those three quantities, then you can calculate the slope of the regression line. Okay. Again, College Board uses B1 to represent the slope, but in class we just used a single lowercase b. Okay. And then the final formula, which again is one that I've scratched out, is the formula for the standard error of the slope. Okay. Excuse me. Now, you never have to use that formula because on the AP exam, they would give this value to you in some computer output. Okay, and so at the end of the year, we were doing confidence intervals for the slope and a t-test for the slope. And for every one of those problems, there was always some computer output to go with it. And one of the values in that output is the standard error of the slope. Okay, so it will always be provided to you. You would never need to calculate it by hand, right? This calculation, would probably take, 30 minutes maybe if you were doing it by hand. So there's no way they're going to ask you to do that on the AP exam. Okay, let's move on to the next page. And so you can see here that we've got some other color-coded sections. In green here is our probability formulas. Right? So they only really provide you with two probability formulas. Okay. Now the first one is the probability of a union, right? So that's the probability of either event A or event B occurring. Okay. So College Board is going to use the set notation, right? The union symbol and the intersection symbol. But you are going to probably want to remember the words that those symbols represent. Okay, so this symbol is for the word or, and this symbol here is for the word and. Okay, so really this formula is read as the probability of A or B equals the overall probability of A plus the overall probability of B minus any overlap between the events. And the overlap is the probability of A and B. Okay. All right, the second probability formula that they give you is for conditional probabilities. And you would automatically recognize that because of the line here, which stands for the phrase given that. Okay. So I've rewritten this formula using words instead of symbols. It's the probability of A given B, and it equals the probability of both events occurring, A and B, divided by the overall probability of B. Okay. There is a pretty fair chance that you would actually have to use these formulas during the exam. All right. Our next section is on random variables. And so we have the expected value formula. It's the sum of the product of each value with its probability. And then we have a formula for the variance for a random variable. It's another summation formula. Okay. So between the two, I'd say there's a pretty good chance that you'd have to use the first one. In fact, I think every mock exam that we've done so far, there's been at least one FRQ question that required the use of the expected value formula. Okay. The variance one, I'm not so sure whether you'd actually have to use that or not. Now, there is a shortcut to finding the expected value and standard deviation for a random variable. And that would be if you put the values of the random variable in list 1 and the probabilities in list 2, and then you ran the one-var-stats command. Okay, if you were to do that, then it would tell you the mean and the, not the variance, but it'll tell you the mean and the standard deviation of the random variable. And if you wanted to find the variance, then you just raise the standard deviation to the second power. If you had the variance, then you would take its square root, and that would give you the standard deviation. All right. There is a very, very good chance, a very high chance probability that you would have to use some of these next formulas. These are the formulas for binomial settings or binomial random variables. Okay. Now the first formula is the one for calculating a binomial probability. For instance, if I toss a coin 10 times, what's the probability that I get 3 tails? Right? So I could use this formula to calculate that probability. Okay. Now there is a little shortcut command on your calculator, which is the binom PDF command. You would have to enter the number of trials, the probability of success, and K is the number of successes that you want to occur. Okay. Now if you know that you've got a binomial setting, then the mean is very easy to calculate. It's just the number of trials times the probability of success. And the standard deviation can also be very easily calculated just from knowing the number of trials and the probability of success, N and P. Okay. So you want to make sure that when you get your exam, you maybe draw a little box or something around these 3 formulas and then just write, well, it says here binomial, so it's pretty clear. So that anytime you run into either a multiple choice question or an FRQ, and you know it's a binomial setting, you'll automatically turn back to these 3 formulas. Okay. All right, so now we're on the bottom of page 2 of the formula sheet. And what we've got here is formulas regarding sampling distributions. Okay, so a sampling distribution is essentially a graph of the results of many samples all taken from the same population. Okay. And so I've made, well, I've done my best, right, these little stick figures, to kind of recreate those diagrams that we looked at in class. Okay. So over here on the left, this little stick figure drawing represents some large population. Maybe it's all Americans, right? All 300 million, Americans. Okay. And then in that population, there is some parameter, right? In this case, it would be the population proportion. Okay. And then what happens next is we take an SRS, a sample from that population, and we calculate a sample proportion. We take a second sample, calculate a different sample proportion, and a third, and a fourth, and a fifth, and we just continue that. So we take multiple samples, and then we compute multiple sample proportions, which, by the way, are all going to be slightly different from each other. And then if we collect all those sample proportions and plot them out in a dot plot, what you will find is that the dot plot takes a roughly normal shape. The center here, right, the results of all these sample proportions will be centered around P, the true proportion, right? And then the spread of all these sample proportions can be found with this formula here. Okay, so these two formulas here that have P hat as a subscript refer to the sampling distribution of the sample proportion. Okay, so the center and the spread of that sampling distribution. All right. The next two formulas that I've sectioned off here in black are for the sampling distribution of X bar, the sample mean. Okay, so same kind of idea. We've got some large population, thousands or millions of individuals, and in that population there is some true mean, right? Some population mean mu. We take multiple samples from that population. For each sample, we calculate a sample mean, which, again, all these will be slightly different from each other. Okay? But when we collect them all and graph them, for instance, as a dot plot, we get an approximately normal shape. The center of all these sample means will be mu, right? So our sample means will cluster or center around the true population mean. Okay? And then the spread, or standard deviation of this distribution, can be calculated by this simple formula. Okay, it's the population standard deviation divided by a factor of root n. Okay, right. So any problem that you run into that mentions sampling distribution, you're going to want to refer back to some of these four formulas. Okay, right. So thanks for sticking with me so far. I know this is going to be a long video. We're on the third page now of the formula sheet. And this page is all the formulas that you would need for inference. Okay? Inference includes any confidence interval problem or any hypothesis test problem. Okay? Now, of course, you want to remember that our strategy or our plan of attack is to use the four-step process. So you need to state, plan, do, and conclude. Okay? Right. So on the sheet, what they have here are the formulas that you would use for the do step. Right? So if you were to calculate a confidence interval, we have the generic form of that, right? Statistic plus or minus critical value times the standard deviation of the statistic. And then for a test statistic, we've got, again, the generic form, statistic minus parameter divided by the standard deviation of the statistic. Okay. So below those generic formulas, we've got a chart for single sample problems. And so there's a column for statistic. So you would plug this into, where it says statistic in the generic formula. And then they have the standard deviation of the statistic, which again you would plug in here. Okay. So if you have a single sample and it's about means, right, your statistic is the sample mean, and your standard deviation is sigma over root n, chances are you are not going to know sigma. You won't know the population standard deviation. So you'll estimate it with the sample standard deviation. Okay, so you're actually going to use Sx over root n in the formula here or in the formula here. Okay. All Right, the commands that you would use on the calculator would be t-interval or t-test. Okay. Right, now if you had a single sample and it was about proportions, then p hat would be your statistic. All right, and so that would go here and here. Um, this expression would be the standard deviation of the statistic. Okay. Which you could use this for a hypothesis test, because a hypothesis test will give you a value to use for the true proportion. But for a confidence interval, you'd have to estimate it by using the sample proportions instead of the true proportion. Okay. Again, the calculator commands related to single sample inference problems about proportions are one prop z int and one prop z test. All right, moving down, we have a little chart here for two sample problems. So if you're looking at the difference of two means, then x bar 1 minus x bar 2 would be what you use for the statistic. Okay, this expression here is what you'd use for the standard deviation. Again, sigma refers to a population standard deviation, which you wouldn't know. So you'd have to estimate those sigmas with s's, sample standard deviations. Okay, so a very minor change. Okay. The calculator commands would be the toSamp tint and toSample tTest. Okay. And then if you have a problem where you're comparing proportions, then p hat 1 minus p hat 2 would be your statistic. This expression here would be the standard deviation of your statistic. Okay. Again, these represent the true proportions, which if you didn't know, then you would estimate it with sample proportions. So just put hats over the p's, and then you're good to go. Okay. Oops. So the calculator commands for doing tests and intervals dealing with true proportions are listed over here: 2prop z int and 2prop z test. And then finally at the bottom we have the generic chi-square test statistic formula, which you would use for a goodness of fit test, a test for homogeneity, or a test for association. Okay, it's all the same formula. Okay, now the TI-84s have commands for doing those things. So there's a command called chi-square GOF test, and then one that's just called chi-square test. Okay. For the goodness of fit test, I believe you put the observed counts in list 1, and you put the, can't remember if you put the probabilities or you put the expected counts in list 2. All right. So you have to look that up on your own. I'm sorry, I don't remember. For the chi-square test, you would use the matrices. So you'd put the observed counts from your two-way table into matrix A, and then you just run the test. Okay. All right, so those are the excuse me, 3 formula sheets. Now we're getting to the tables, right? So all these tables, all they do is they tell you areas under different curves, right? So this is table A, which just lists a bunch of areas under a normal curve, and it's 2 pages long. And then this is table B, which lists areas under a t-distribution or t-curve. And then table C is areas under chi-square curves. Okay. So you can actually use the tables to find the areas. This is how it was done, in the olden days before the advancement of technology. Okay, but you also have some commands on your calculator to do the exact same thing, right? So if you want to find the area under any normal curve, you can use the normal CDF command. Okay, you would just put in the lower bound where the shading begins, the upper bound where the shading starts, the mean of the distribution, and the standard deviation. Okay. So that command will produce an area. Okay. You can also work backwards, right? You can use the inverse normal command. So let's say let's say you know that this is the bottom 10% of the curve, and you want to find the z-score, right? So you can use the inverse normal command to do that, right? To go from an area back to a z-score. So here, table B, again, it's finding areas under t-distributions. So you can look it up in the table, or you can use the tcdf command on your calculator. You would just input the lower end where the shading begins, the upper end where the shading stops, and then the degrees of freedom. I doubt that you would really have to use this command And I doubt that you would really have to use this table because really the only time we use t-distributions is when we're doing um, like confidence intervals or hypothesis tests for means. And we have the calculator commands for those already, and the calculator commands automatically would tell you the tail area. So I doubt that you'd really have to really use this tcdf command. Okay. Now, what table B is really good for is finding critical values, right? Let me go back up here. Right, so when we're doing a confidence interval, right, you have to find the critical value, which is either a z-score or a number from the t-distribution. Right. So if you know your confidence level, you look it up here. If you know the degrees of freedom, you'd look it up here, and then you'd find the critical value. Okay. The last row, though, the one labeled infinity, these are all z-scores. Right? So these are the z-scores that we would use as critical values when we're doing confidence intervals for proportions. Okay. And then the last table, this is for the areas of chi-square curves. So you can look up the area, using the table, which I doubt you'd really have to do, because both the chi-square GOF test and the chi-square test tell you what the areas are. So it's kind of automated for you. You can also use this command, although I highly doubt that you would ever have to use it. Okay. And that pretty much wraps up the formula sheets. Okay. So here are the big takeaways. So let's go back to the beginning and just give you a quick summary. Okay. These formulas, highly doubt that you'd use them. Okay. But make sure you know how to use the one-var-stats command. Okay. This, I would say, is important to know. Well, not that one, but this one, right? Know the general form of the least squares regression line, okay? Predicted y value equals a plus bx, intercept plus slope times your explanatory, okay? So you got to know that form, okay? I would say this is maybe nice to know. I mean, I bet there would probably be maybe one or two multiple choice questions where you might need to use these formulas, right? And that's it. Right, for this page, right? You don't need that one, you don't need that one, you do not need that one. Okay. These, I would say, know them, or just know where they are, okay? Same thing with this, know the expected value formula, right? You will definitely need to use that at some point during the exam, okay? But also remember that you can use one-var-stats, where list 1 has the values and list 2 has the probabilities, right? So know that as well. Okay. For sure, know where the binomial formulas are. Like section it off or something. Like you will definitely need to use this during the exam. Okay. Sampling distributions. You probably need to use this a few times, maybe. Yeah. Probably good to know. I think it's better to just understand this process. Like seeing the formulas is like, oh, yeah, I don't really remember what that is. But remembering the process, like, oh, we have this population, we take multiple samples, we gather all these statistics, we graph the statistics out, and we get this pattern, right? This beautiful, approximately normal shape. The results should be centered around the true value, and we are able to calculate the spread or the variation in these results. Okay, so that's all these two formulas are, right? Telling you the center of all these results that you have and how spread out all your results are. Okay. All right, so here's where I think you've got to spend some time, and maybe at the very beginning of the exam, you maybe write these comments in, right? So as soon as you get your exam, you find this page and you need to write in the symbol X bar, right? You need to write the symbol p hat, okay? You should probably write this other version, right, of the standard deviation, right? So there's the version they give you with the population value, but you also should write the version of it with the sample value, okay? Same thing here, okay? Same thing here and here, and here and here, okay? And yeah, that's my advice for the formula sheet, okay? Wow, so Didn't realize it's almost half an hour long, so it's a really long video. But I do hope you watch it. I do hope it's useful, and of course, I wish you the best of luck on the exam. All right, thanks for watching.